Welcome to this FP2 video on second order differential equations, and in this video we'll look at second order homogeneous differential equations. So a second order differential equation is just a differential equation that contains second derivatives. So we looked at the first order differential equations, which contained, the first derivative, dy by dx. Now we're looking at second order, which goes up to d2y by dx squared. Now let's look at just a really simple example. So here's an example of a really simple second order differential equation. Okay, not a homogeneous one, just a second order differential equation. And if I was basically to integrate this to get to y equals, I would integrate once, so that would give me dy by dx, and that would be then 24x squared over 2. I was just going to do it in one go, plus a. And obviously the 2 will cancel with the 24, leaving me with 12. So that's 12x squared plus a. And that was my dy by dx. And then if I integrate again, I'd get y. And this would be 12x cubed over 3 plus ax plus b. And 3 will cancel with that, giving me 4. So y equals 4x cubed plus ax plus b. And this would be the general solution to the differential equation. Now, obviously, if we wanted to find a particular solution, we would then need two sets of boundary conditions because we have two different unknown constants here. Okay, so they'd have to give us two pieces of information for us to find a particular solution to this equation. So that's just a very quick example just on a second order differential equation. Now let's talk about second order homogeneous differential equations. So the types of differential equations that we're going to be looking to solve, basically linear differential equations, is going to be of the form a d2y by dx squared plus b dy by dx plus c y equals 0. Okay, now when they're of this form with the equals on the right hand side, these ones are called second order homogeneous differential equations with constant coefficients. Okay, now sometimes this is written just to make it a little bit easier to write, a, and then instead of d2y by dx squared, it's a y with 2 dashes above it, plus b, and then this is a y with 1 dash above it, and cy equals 0. So sometimes written like that just in terms of notation, and that is just to be easier, quicker, cleaner than writing the full d2y by dx squared, dy by dx, and so on. Now we can use some of the techniques from the last chapter, on last set of videos on first order differential equations, to get us down to a general solution. Okay, and there's lots of kind of information out there. I'm not going to go through all of this in this video. Okay, it's quite easy to find if you are interested. I'm just going to get into how we go about finding the general solution and questions that you're going to experience in your exam. So with that in mind, I need to give you a little bit more information. Okay, so we've got an equation am squared plus bm plus c equals 0. This is known as the auxiliary equation. And the nature of the roots of this equation, okay, determine the general solution to the differential equation that we have here. So we have a few kind of possible scenarios, okay, and the roots we'll be using is roots alpha and beta. Okay, so our options are 1 when b squared is greater than 4ac. Okay, that is when we get two distinct real roots. Okay, and then the general solution will be of the form ae to the alpha x plus be to the beta x. Okay, where a and b are just arbitrary constants. So that's kind of one option. The second option is when b squared equals 4ac. Okay, that is when we get one repeated root. So it's like alpha is the same as beta, so it's just like both are alpha. And then the general solution will be of this form: a plus bx e to the alpha x. Okay, again where a and b are arbitrary constants. And then there's the third scenario, and you probably guessed it by now, is b squared is less than 4ac. So this one now has two complex roots. Okay, so the complex roots will be of the form, p plus or minus qi. And this will give us a general solution, okay, of e to the px a cos qx plus b sine qx. Okay, so just put this up here. So this one was alpha and beta are the roots. This one, the second one, then repeated alpha, so just alpha as the roots. And then the third one has complex roots. Okay, so alpha and beta form of p plus or minus qi. Okay, so those are the three scenarios that we're going to get. And I should say, with this complex one, if it's purely imaginary, so not real and imaginary, then this bit will disappear because p will be 0. So this is 0, e to the power 0 is 1, so we're just left with this as our general solution. Okay, so those are the three kind of scenarios. Now let's look at a question. Okay, and these three scenarios is worth learning. By doing questions, you'll start to remember them, and that's the best way to revise them. Okay, to get them to stay in your head, just to do lots of questions. So we're gonna start off with just A. Okay, so the first step here will be to write down the auxiliary equation, and this is simply going to be 3m squared plus 7m plus 2 equals 0. So you can see up here it's a 3m squared plus 7m plus 2 equals 0. And then we've got to solve this equation either by factorizing or by using the quadratic formula. So let's have a look if this one factorizes. So 3m and m. If I make this 2 and this 1, 3m squared, 6m, 1m, 7. Yes, that works. So there we have it. So that produces m equaling minus a third and m equaling minus 2. Now this is the first type. B squared is greater than 4ac, hence we were able to factorize and get two distinct solutions. So this now is going to be the general solution. So I could write the general, I will write it in. So it's y equals a e to the minus 1/3 x plus b e to the minus 2x, where a and b are arbitrary constants. And that's just getting the general solution to this second order homogeneous differential equation. Bit of a mouthful, I know. Now, part B is verify that your answer to part A satisfies the equation. So our value of y is a e to the minus 1/3 x plus b e to the minus 2x. Now what I want to do is differentiate this. So dy by dx is minus 1/3 a e to the minus 1/3 x minus 2 b e to the minus 2x. And then I want to differentiate a second time to get my d2y by dx squared. And bringing the minus third down, this becomes plus 1/9 a e to the minus 3rd x. And this becomes plus 4 b e to the minus 2x. Now I've got a term in y, dy by dx and d2y by dx. So if I substitute into this left hand side, they should all cancel with each other, leaving me with 0. So that's what I do now. So 3 times 1/9 a e to the minus 1/3 x plus 4 b e to the minus 2x plus 7 times minus 1/3 a e to the minus 1/3 x, oh not plus, minus 2 b e to the minus 2x plus 2. Let me just make a bit of room, just moving that over just to make sure it all fits in. Okay, so that's what I've got, and then I've got to work out what this equals. So first let's expand the brackets. So that gives me 1/3 a e to the minus 1/3 x plus 4/3 b e to the minus 2x minus 7/3 a e to the minus 1/3 x minus 14 b e to the minus 2x plus 2 a e to the minus 1/3 x plus 2 b e to the minus 2x. And sorry, just this bit here, it's not 4/3, is it? It's 3 times 4, so this is 12. Yeah, 3 times 4. Don't know, I was just thinking of the 9th. I don't know why I wrote the 3 on the bottom there. Right, so let's look at what we've got. 1/3 minus 7/3 plus 2. So if I write a to the e minus 1/3 x, and I get 1/3 minus 7/3 plus 2 plus b e to the minus 2x, and that is 12 minus 14 plus 2. Now, a third minus 7/3 is going to be minus 2. Just double check my calculator. Yeah, minus 2. Minus 2 plus 2 is going to be 0. And 12 minus 14 plus 2 is also 0. So this equals 0 as required. Okay, and there we have it, verified that it does satisfy the equation. Okay, now let's have a look at another couple of examples. So this one show that y equals a plus bx times by e to the minus 5 x. Sorry, I missed the x. So it satisfies the differential equation d2y by dx squared plus 10 dy by dx plus 25y. So this is like part B that we just looked at. So I need to take my solution that I want to test, and I need to differentiate twice. Okay. Now, before I differentiate, it's probably best to expand this bracket. So a e to the minus 5x plus b x e to the minus 5x. So differentiating a e to the minus 5x is going to be minus 5 a e to the minus 5x. Now differentiating bx e to the minus 5x, that's going to be product rule. Okay, so it's going to be, bx times the differential of e to the minus 5x. So that'll be minus 5 bx e to the minus 5x. And then that's going to be the differential of bx, which would just be b times this one, so plus b e to the minus 5x. So product rule is differentiate times this and differentiate times this. Okay, so that gives me my dy by dx. Now I need to find d2y by dx squared. So this is going to be 25a e to the minus 5x. Now this is going to be the product rule. So this times the differential of this. So plus 25 bx e to the minus 5x. And then it's going to be this differentiated, which is minus 5b times this. So minus 5b e to the minus 5x. And now we're doing be to the minus 5x. So it's going to be minus 5b e to the minus 5x. Okay, so I can see here I've got two terms here that can be collated into one. So we've got 25e to the 25a e to the minus 5x plus 25b x e to the minus 5x minus 10b e to the minus 5x. Now I need to substitute into here. So this one, so 25a e to the minus 5x plus 25bx e to the minus 5x minus 10b e to the minus 5x. Now this is plus 10 lots of my dy by dx plus 25 lots of my y. And there we have it. Now we just need to simplify this and hopefully show that this equals to 0. So I'll do that now. And there we have it. So y equals a plus bx brackets e to the minus 5x is the solution to this this differential equation. Okay, let's find the general solution to this equation. So first thing we need to do is to find the auxiliary equation. So that's going to be 16m squared plus 8m plus 1 equals 0. And then I need to solve this. So usually I always check for if we're able to factorize first, because that's easier. In this case, it will factorize, I think. And obviously, you know, using the quadratic formula then is your other scenario. So 4m and 4m, 1 and 1, plus and plus. So this gives me 16m squared, 4m and 4m is 8m, and 1 times 1 is 1. So this is the same as 4m plus 1 squared. So it's a repeated root. Okay, so we've got m equals minus a quarter. Okay, so that means the general solution is y equals a plus bx e to the minus 1/4 x. And there we have it. Solve this general solution to this differential equation. Let's have a look at another scenario. So let's start off with the auxiliary equation. So m squared minus 4m plus 5 equals 0. So 1 times 5 will give me 5, and 1 take away 5 will give me minus 4. But to get a positive 5 at the end, they either have to both be positive or both negative, which doesn't work. So let me just check b squared minus 4ac to see what happens. And we've got minus 4 squared minus 4 times 1 times 5. So I've got 16 minus 20. So less than 0. Okay, so this one's going to give me a differential equation. So let's start off by finding what that is. And I'm going to use a quadratic formula. So minus b is going to be 4 plus or minus minus b squared minus 4ac all over 2 times a. So 4 plus or minus, now we know inside the square root we've done up here, 16 take away 20 is minus 4, and then that is over 2. So minus 4 will be the square root of 4, which is 2, so it's going to be 2i over 2, so this will be 2 plus or minus I. So this now is my solutions to the auxiliary equation, which means that this needs to be of the form y equals e to the px and then a cos qx plus b sine qx. Okay, p is the real value, so we've got y equals e to the 2x a cos x plus b sine x, because obviously the I value there is just 1. And there we have the solutions to this problem. Okay, hopefully this makes sense. So I've done an example where b squared minus 4ac is positive, greater than 0, where b squared minus 4ac equals 0, and where b squared minus 4ac is less than 0, so negative complex numbers. So final example. Now this is one that should, if I pick the right values, give us an equation that is purely imaginary. So we've got m squared plus 81 equals 0. So that is my auxiliary equation, or solution. Yeah, auxiliary equation. I don't know what I'm saying here. So m squared equals minus 81. M is the square root of minus 81, which is, and that's plus or minus 9i. So in this case, m is solely imaginary. Okay, so if we look at the general solution again, what I can see here, p in mine, it doesn't exist, so p is 0. So this is 0, this is 1, so I've only got this scenario happening. So y equals a cos, and q is this value 9. 9x plus b sine 9x. Okay, and that's the general solution to this differential equation. Nice, straightforward, not too difficult. Hopefully you've found some use out of this video. If you have, hit the like button, give me a thumbs up, comment down below, let me know how you're doing with this, and if you're willing and able to, hit that join button. Even if it's just for a month, it'll all help me out, and the more help I get, the more videos I can make. Simple as. Right, let's look at a few questions for you to do. So I'll give you, I think, 5 questions, and then at the end I will go through them as usual. So I've picked 5 questions here, basically covering the 3 main types and really that 4th kind of unique type of, not unique, just a subtype of the negative one. I think that's what I've got. And then question 5 is just a past paper question that I found on it. Okay, so pause the video whenever you're ready to have a go. Okay, welcome back. Let's have a look at how you did. So you should have got the equation 15m squared minus 7m minus 2 equals 0. This was able to factorize this with a 5m and a 3m. And this was 1 and a 2, like that. So let's just double check. 15m squared minus 10 plus 3 is minus 7 and minus 2. So you get m equals minus 1/5 and m equals 2/3 as our 2 scenarios there. Y equals ae to the minus 5th x plus be to the 2/3 x. Incidentally, it doesn't matter if you've got your minus a 5th x here and your minus and your 2/3 x here. Okay, it's exactly the same answer as this. So don't stress if you did it the other way around. Right, let's have a look at the second one. Right, you know the scenario by now. So 4m squared plus 20m plus 25 equals 0. Oh, no, it's not going to be a 4m. So that gives me 4m squared. 10m plus 10m is the 20m, and 5 times 5 is 25. So this is 2m plus 5 squared equals 0. So m equals minus 5 over 2. Okay, and now this is going to be of the form a plus bx e to the minus 5 over 2x. Okay, and that is the second one done. Let's move on to the third one. Okay, third one, nice and easy. So taking the square root, plus or minus root of minus 25, which is plus or minus 5i. So this one now is just a purely imaginary. So it's y equals a cos 5x plus b sine 5x. And again, it doesn't matter if you've written a sine 5x plus b cos 5x. Okay, it's the same thing. You've just swapped your a's and b's around, but they're just constants anyway. Right, let's move on to the fourth one. So we've got m squared plus root 3m plus 3 equals 0. So as you probably guessed by now, this is going to be another complex number, a real and complex number, you know. So it's going to be, if we just check b squared minus 4ac, we got b squared is 3 minus 4 times 1 times 3. That's going to be 3 minus 12, which is minus 9. Okay, which is obviously then going to be complex. So m equals minus b, so minus root 3 plus or minus square root of minus 9 all over 2a. So we've got minus root 3 plus or minus 3i all over 2. Now if I just separate them out, minus 3 over 2, sorry, root 3 over 2, plus or minus 3i over 2. Okay, or 3 over 2i. Now the general solution to this one is e to the power. Now it's going to be the real value, so minus root 3 over 2x, and then brackets, and it's a cos 3 over 2x plus b sine 3 over 2x. And there we have it. Okay, and that is now done and dusted. Right, let's have a look at the exam question. So we've got this differential equation where k is a real constant, and we need to find it in these scenarios. Right, let me just make a little bit of room. Okay, now we've got some room. So let's write down the auxiliary equation. So we've got m squared plus 2km plus 9 equals 0. So we want to solve this. There's a various scenarios, so let's use the formula, the quadratic formula. So minus 2k plus or minus square root of 2k squared, so 4k squared, minus 4 times 1 times 9 all over 2 times 1. So this gives me minus 2k plus or minus the square root, this is 4k squared, minus, now we've got 4 times 9. So let's make it a little bit easier and just take the 4 outside a bracket. So we've got k squared minus 9 inside my brackets. And this then is all over 2. So there we kind of have it. Now minus 2k, we can do a bit of simplifying. The root 4 will be 2 root k squared minus 9 over 2. The 2's will cancel, so minus k plus or minus the square root of k squared minus 9. And there we have the solution, well, kind of the solution to this auxiliary equation here. Now let's look at what happens in each of our scenarios. So scenario 1 is when k is greater than 0. Okay, so this means that k squared is going to be greater than 9. Now when k is greater than 9, in this case this is going to be a positive value, so it's going to give me two unique solutions, isn't it? So solution 1 would be this, minus k plus this root, and the other solution would be minus k minus this root. So this is going to be solved by ya. Now it's going to be minus k plus root k squared minus 9 times x plus b, and then it's going to be minus k minus root k squared minus 9 times x. Right, second scenario when k is less than 3. So when k is less than 3, then that transpires that k squared must be less than 9. Okay, which just means the b squared minus 4ac is going to be negative, isn't it? So in that scenario, you know, my m is going to be minus k plus or minus, and then this scenario is going to be, this k is going to be less than 9, so this is going to be a negative value. Okay, does that kind of make sense? So what I would do is, if I take the square root of minus 1 outside, which is my I, and then the square root, and then let's put this k squared minus 9 inside the modulus sign, because obviously it can't be negative again if I've taken the negative out. So we know it's negative, and I've taken that negative out. So this scenario is what is happening, and then, oh sorry, I've put y's in all of these, but, and x's at the top, but it's t's and x's. So I apologize, I need to rub a little bit out. So these x's need to go to t's, and this y needs to go to an x. It's the same thing, so it's just get my lettering right. So for when it's b squared minus 4ac is less than 1, we'll have e to the, now the positive one, so the minus kt, and then we've got a cos, and then it's this, isn't it, the bit with the I, so square root of k squared minus 9 t plus b sine square root of k squared minus 9 t, and then we have it. And then scenario 3 is when k is equal to 3, so that means that k squared is equal to 9. So that means that inside the square root will be 0. So it's going to be repeated roots for this one. So I'm going to get x equals a plus bt. Remember t instead of x now. E to the minus kt. Okay, so that is now pretty straightforward. Remember, where this is 0, my only solution is this minus k repeated. So that's part A done. Let's have a look at part B. So part B says, in the case where k equals 2, find the general solution and describe what happens to x as t tends towards infinity. So from earlier I had minus k, didn't I? So minus 2 plus or minus, and then inside the square root would be 4 minus 9, wouldn't it? Which would be minus 5. So it's going to be 5i. So that is my solution. I haven't bothered with any more working out because it's just from the part A. So x is equal to e to the minus 2t a cos 5t plus b sine 5t. Okay. Oh, hang on. It's not 5. It's square root of 5. Rushing ahead there. Isn't it? Because it's a square root, so it's 4 minus 9 minus 5, but it's the square root of 5i, isn't it? My apologies. So that is part 1 done for B. Part 2, describe what happens to x as t tends towards infinity. So, as t tends towards infinity, this here is going to tend towards 0, isn't it? Because this is 1 over e to the power 2t. Okay, which as it tends towards infinity would be like infinity. 1 over infinity is basically going towards 0. So as t tends towards infinity, x tends towards 0. And there we have it, job done. So if you found this video useful, please smash that like button, comment down below. I don't always get a chance to reply to everyone, but I do read most of the comments, okay? And I do reply where I can. Sometimes I'm just reading them when I'm on my phone. Don't always get a chance to reply to everyone, but I do like to have a look at what people are saying. So please comment down below, and also consider joining. Okay, you can join for 1 month, you can join for longer. I know it doesn't really give you any benefits as such. Okay, just I do tend to prioritize replying to questions from my members. Okay, because a lot of people are asking questions and it is pretty hard to reply to everyone. So I do read a lot of the questions, but I do prioritize replying to members. Anyway, any little help that you can give me helps me out massively. If everyone give a little, then I would basically be able to commit to making a lot more videos. Okay, anyway, see you in the next one. Bye bye.